All right, so here we've got the vocab for this unit for force and motion, and you can find these definitions in the force and motion Quizlet that's linked at the bottom of the slide. I'm going to go through this. You can pause it as you find necessary, but I don't plan on going very slow and waiting on you like I would in class. So force is a push or pull exerted on an object. So when you push or pull something, that is, you're using force. You're adding force. You're adding a push or a pull to an object, and that is force. Speed is the distance an object travels per unit of time. An object travels per unit of time. So speed is how fast it goes. I'm sorry, speed is how fast something is going, if you want to think about it that way, but it's the distance it covers with a period of time. So feet per second, or miles per hour, or inches per day, or whatever. I mean, you could just any kind of distance per unit of time, that is speed. Time is already there. Time is measured in seconds. Should be a pretty easy one. Mass is the amount of matter of an object. Amount of matter in an object, the things that make it up. We talked about that, the atoms that make that stuff, the mass. Mass does not change if you go from one planet to another. Distance is the length an object travels. The length an object travels. That's going to be different than what we talk about displacement. The length an object travels would be like you moving from, driving from your house to the gas station. That is a distance. Displacement is a little bit different. Displacement would be distance from the starting point to the ending point. So if you drove from your house to the gas station back to your house, you would have traveled a good bit of distance. You would have not traveled any. You have not been displaced at all. You've not moved from your starting location compared to your ending location. We'll talk more about that later. Acceleration is the rate of change of velocity. The rate of change of velocity. This can be calculated by dividing. This can be calculated by dividing the change in velocity by the time it takes the change to occur. So acceleration is the rate of change of velocity. If you want to think of a short definition, that's it, the rate of change of velocity. This can be calculated by dividing the change in velocity by the time it takes the change to occur. The most common one that we're going to come across is gravity, which gravity pulls you down faster and faster and faster each second. It is accelerating. So it's not just the movement of something in a direction. It is actually the speed at which it's changing. It's getting faster and faster. So if I am in a car and I put the gas pedal all the way to the floor, I am speeding up. I'm not just, I'm accelerating, I guess would be a better way of saying I'm accelerating. And if I'm just keeping it steady, I'm going the same speed, but this is the change in speed over time. So it's, we'll talk about this with a graph, and I think it'll make more sense when we look at this with a graph. But simply put, it's the rate of change of velocity. A Newton. This is a measurement of force. So when we're measuring force, it's going to be, the unit is going to be a Newton. Gravity is an attractive force, not like you really like it, but it's a force that deals with attraction between two objects that depends on two things: the mass of the objects and the distance between them. So the sun would pull you down to it very, very, if you were on the surface of the sun and you could not, get burned up, the sun would pull you down. You would feel the gravity of the sun a lot more on the surface of the sun than you do here, because even though the mass of the object does not change, the distance between them has. Wait 1 second. Sorry, I thought I had to sneeze. Excuse me. So the distance between the objects matters, and the mass of the objects matters. Newton's first, second, and third law, we'll jump back to that in just a second. Let's jump down to inertia. It's a tendency. Inertia is the tendency of an object to resist change in its motion. You've experienced this. We'll talk about it in a second. If it's moving, it, I'll put in quotes, wants to keep moving. If it is still, it, again, quotes, wants to stay still. And you've experienced this if, so I put quotation marks around want because it's not an actual want. An object doesn't want to do anything, but we use that as kind of anthropomorphism or personification. It's putting human characteristics on something that's not human. So if you're in a car and somebody slams on the brakes, then your body wants to continue moving forward. So your body's moving forward at 40 miles an hour, you slam on the brakes, and your body's going to want to continue moving 40 miles an hour. That's why you have a seatbelt and airbags and other safety devices that keep you where you are, because you want to keep going if you're going. And if you've ever pushed something like a car or something heavy, once you get it moving, it seems easier to keep it moving because it's got some inertia. It's hard to overcome this wanting to stay still part. So once something starts moving, it seems to be, anecdotally, it just seems to be able to, it seems easier to keep it moving than it is to get it moving. So velocity is the speed of an object in a specific direction. The speed of an object in a specific direction. Friction, we've heard of friction, you've experienced this a lot. Force that opposes the sliding motion between two touching surfaces. And you could make that shorter probably. But you've experienced this, rubbing your hands together. You can rub them together very easily if they're just barely touching. You push down on them, it takes more force to slide down. Friction, that's an experience, you experiencing friction. Motion is a change in an object's position to a reference point. Change in an object's position to a reference point is motion. All right, let's talk about these three laws. I think I'm going to pause it and let you see what's there. Or you can just kind of jump forward to the next video, or I'll put it in the next scene. Or you can always go to the Quizlet and just get them from there. But these three laws, Newton's first law states that an object moving at a velocity keeps moving at a velocity unless an outside force acts on it. The way I memorize this is an object in motion stays in motion, an object at rest stays at rest. That's what we're going to put. An object in motion stays in motion, an object at rest stays at rest unless acted upon by an outside force. So you roll a bowling ball will go completely around the world unless something stops it, which it will, but it will keep going unless something stops it. Second law states that more force generates more acceleration for a given mass, but more mass means less acceleration from a given force. We can see this in a formula. We're going to say F equals M times A. That is the formula. We'll talk more about that in class, but that is Newton's second law. Newton's third law states that for every action in nature, there is an equal and opposite reaction. The way that I've heard this and I memorized this is every action has an opposite and equal reaction. So there's your vocab. Go ahead and study this. Use Quizlet to study this. Use the resources that you've got, Blue Kits, Skim Kits, whatever you can find to study these words.